Hi everyone, welcome to what is this, day 4 of learning from home and learning online. This is the first recording that I'm actually doing from my house since I am now working from home also. So if you see my children walking past in the background or anything like that, you might know. Guys, say hi.
Hi.
You can hear them, they're all hiding under a table back there. Anyways, we are going to start some more probability today. We're going to learn about experimental probability. So let's get going with this. Experimental probability is really the probability you can find after conducting an experiment. We have lots of different experiments we can use, like flipping a coin, picking a card from a deck of cards, rolling a die. Those are very simple experiments. So probability is really the number of times an event occurs over the total number of trials. And we remember we can have it written as a fraction, decimal, or a percent. One example of an experiment that we could do is to flip a coin. And I could keep track of how many times I flipped heads and how many times I flipped tails. So let's say that I flipped heads 15 times and I flipped tails 10 times. Now, if I want to know the experimental probability of flipping heads, I would say my probability is 15 out of a total of 25 tries. So as a fraction, it's 15 out of 25. We can simplify that to be 3 out of 5. Now, I did say you can write it as a fraction, a decimal, or a percent. So just as a reminder, if you did want to write this as a percent, we could change 3/5 into a percent by doing 3 divided by 5 and then times that by 100, and you would get 60%. So 60% of the time I flipped heads. That also means that 40% of the time I flip tails. All right, so let's look at another problem. Here we're going to estimate the probability of drawing a certain colored marble out of a bag. So the bag has red, green, and yellow marbles. The table shows the results after 50 draws. So I want to know the probability of drawing a red marble. So I'm going to write this as the probability of red, which ends up being 15 out of 50. Now you can leave it as a fraction in simplest form. We would divide by 5. That would be 3 out of 10, or write it as a percent. 3 divided by 10 times 100 is 30%. So the probability of picking a red marble is 30%. The probability of drawing a green marble, I'm even using a green pen. The probability of green is 12 out of 50. And simplifying that, we would divide by 2, which ends up being 6 out of 25. And 6 out of 25 as a percent is 24%. I would accept either one of these answers, either the fraction or the percent. So either one works. Okay. Continuing on, if this time we have a bunch of tickets in a bag and we have red, blue, and pink tickets, we could estimate the probability of drawing a red, blue, or pink ticket. In this case, we want to know the probability of a blue ticket. So a blue ticket, the probability of blue would be 112 out of 1,000. Okay, now you can simplify that. You can divide both of those by 4, I believe. 112, let me try that again. 112 divided by 4 is 28. So that would be 28 out of 250, but we can divide again, which would be 14 out of 125, because we can divide those both by 2. So you could leave it as the fraction, or 14 divided by 125 as a percent is 11.2%. So we have an 11.2% of drawing a blue ticket. Okay. If you were giving a table of things that have happened, you can then try to predict who is most likely to win their next game based on probabilities. So if we look at these teams, we have the Huskies, which won 79 out of 138 games. We have the Cougars, who won 85 out of 150, and then the Knights, who won 90 out of 146. Now, for me, it is very difficult to compare these three fractions, so I think it would be much easier to write them as percents. So let me grab my calculator. 79 divided by 138. This would be 57.2%. 85 divided by 150 ends up being 56.7%. And then 90 divided by 146 ends up being 61.6%, meaning that the Knights would be most likely to win their next game because they have the highest percentage of wins. Does that mean they're going to win their next game? Absolutely not. We all know that this is just a probability, so we're looking at what most likely happened. But there can be upsets just like anything else. So we would say the Knights are most likely to win the next game. And when it says justify your answer, all I need is to see that you found out that the Knights would win by 61.6%. All right, so your homework is to continue on Canvas and do the Canvas assignment that is listed next in the module. And then you are done for the day, and make sure you're going on and checking in with all your other classes also to make sure you're getting the work done for those classes, including Phi-Ed and any elective classes you have. Remember, you don't just have math, English, social science. You have Phi-Ed, you have maybe art or facts, whatever your elective is. Have a great day. See you tomorrow.